To understand reactive streams, first let's take a look at the event-driven architecture. For example, in this case, let's say that we have a user and the user places an order, and the order system should notify the payment system, inventory system, and the shipment system about the order. So before the event-driven architecture, the way the systems used to interact with each other is order system used to call payment system directly and the inventory system and the shipment system directly. This introduced several problems which was solved using the event-driven architecture. So what we do in the event-driven architecture, right? In the event-driven architecture, in the center of our system, we have an event bus. So for example, it could be a Kafka, it could be similar systems. When we are sending when we are sending event to the event bus, let's say to the Kafka topic, and from the Kafka topic, we have three subscribers, right? We have a payment system, we have inventory system, and then we have shipment system. So we have one producer, and then we have three consumers. By the way, they can also be named differently. For example, in the Google Cloud Platform, the name is producer and the subscriber. Also, we have an observable, but the point is the same. So we are publishing message, we are pushing message to the event bus, and also on the downstream system side, we have several systems that are one or many systems that are consuming from that event bus. So as I said, we can have multiple producers, we can have multiple consumers. For example, in this case, let's say we have three order systems, right? And they are publishing to the event bus, and on the consumer side, we have three consumers that which are consuming those orders. So this is event-driven architecture. Also, we are calling it reactive processing. So what's that mean in this case? Reactive processing means that our downstream systems reacts to the event. So we have event, and our downstream system reacts to those events. Also, in this case, in case of the event-driven architecture, or let's say that in the reactive processing, so what we have is we have a back pressure handled by the default. So what's that mean? Let's say that order system, it produces 100,000 messages. Order system 1, 2, 3, they produce, let's say, 100,000 messages in a minute, right? But on the payment side, we can handle only 20,000 messages in a minute. So what it means is we need to have a mechanism on the payment, on the downstream system side to handle as many messages as we can, right? So for example, on the payment side, if we want to only consume 100,000 messages, we want to consume only 20,000 messages in a minute, then we should be able to do that. So that's called the back pressure. So in this case is from payment, it's handled by default. So what does that mean? For example, in Kafka, right? It's handled by default. So payment system consumes as many messages as it can process. So for example, it consumes let's say that in a second it consumes 1,000 message or whatever the value that it can process. So it up to the downstream system to consume those messages and the process. So considering all this, what is the advantages of the event-driven architecture, right? There are a number of the advantages, but I marked in the yellow color those that I think is important to notice here. The first one is the loose complement, right? So what's that mean is that the producers don't know about who the consumer event. So as far as that system is concerned, in our case, the order system, right? It produces the event, and on the downstream side, it can be consumed by one system or by many systems, and so on. Another one is that, so one of the most important one is that it's asynchronous. So what's that mean is that the events are processed in the background without blocking. So from the producer side, again, as far as the producer is concerned, producers produce the event, and it's up to the downstream systems to consume those events and process them properly. Another one is the scalability. So each service or consumer can scale independently. So let's say that we want to consume more messages let's say we want to consume more messages on the payment system side, right? So we can scale that independently. So also it's extensible, which means that the new consumers can be added without changing the existing code. So it's resilient, which means that a failure in one system will not affect the others. Also, it's responsive, it's observable, and flexible, and so on. So these are the advantages of using the event-driven architecture. So now let's go to another example. Let's say that we have, let's slowly go to the reactive programming. So we have an event-driven architecture, and let's say that the sub part of it, we can say that the sub part of the event-driven architecture is the reactive programming. So what I mean by that? So for example, in this case, let's say that we have an event and we are sending an event, and that event need to be processed. So again, asynchronously, right? That event needs to be saved to the database. That event needs to be logged, and that event, so we need to send a notification about that event. So right, 3 different processes that should happen asynchronously, right? So we are sending an event, and that event should be asynchronously processed by these 3 systems. So again, one of the ways that we can do that is event-driven architecture, which means that we can place an event bus such as Kafka in the middle of it, and we can publish all our messages to Kafka, and on the downstream side, these services, right, saving to the database, logging, and notification can consume and process those messages. But what if we want to do that as a part of the one JVM? Let's say that we don't need to spin up a separate Kafka cluster. We don't need to spin up a separate Zookeeper and so on. We just need to, as a part of one JVM, as a part of one within the one JVM, as a part of one program, we want to consume message and save the message to the database, log, and send notification, and we want to do that asynchronously. That's where reactive programming comes into the picture in Java. So basically, it means that we are reacting to the event. So whenever we receive an event, we are processing that event asynchronously by considering the back pressure also. It's an important concept that I've mentioned earlier. Now that we know that what is the reactive programming, let's take a look at how reactive programming has evolved in Java. So let's start first with the pre-reactive era, right? Which is that before 2011. So before 2011, the way how we could create an asynchronous code, asynchronous program, or asynchronous or reactive program in Java is to use a feature. So feature has several disadvantages. One is that it has a callback issue, it has no unified abstraction, and that there is no back pressure handling in the future. And also feature can be blocking. For example, in this case, if we get our future, if they will try to get the value from our future, then in that case, this part of the code is blocking. So the next one is that was introduced around 2012 and 2013 is RxJava 1. RxJava 1 was introduced by Netflix as a counterpart to whatever already existed in the C#, observable pattern in the C#. So basically, observable pattern is another way to saying that the producer, right? I've already mentioned that we use either producer or publisher. Another way to say that we have a publisher is observable. So in this case, what we have is that we have observable that, for example, in this specific example, right, publishes 3 events, A, B, and C. And what we do is we are mapping those events to lowercase, and we have a subscribers that basically subscribe and prints those events. So the biggest disadvantage of the RxJava 1 was that it wasn't handling the back pressure. So the next one is that around 2015, the way how we can create a reactive stream APIs, frameworks, libraries, and so on, it was streamlined, and 4 interfaces as a part of the reactive stream specification, 4 interfaces, publisher, subscriber, subscription, and the processor that I've mentioned here, they were introduced. These 4 interfaces are the backbone. They are the main foundation for the reactor, for the Akka streams, for the RxJava 2, and the Flow API that we are going to review a bit later. So the next one is In 2016, RX1 was improved to the RX Java 2. Flowable was introduced in order to handle the back pressure. Again, the flowable is another way of saying of a publisher, but in this case, it was introduced in order to handle the back pressure in reactive streams. So the next one is that Java, so starting from the Java 9 in 2017, Flow API was introduced. It's a part of the JDK, so you don't have to include any library, any external framework in order to use the reactive streams in Java. So it's a part of the JDK. So now let's go and take a look one example of it. In here, I have an example for the stock price streams. So basically what we have here, right? So what we have here is we are creating one publisher and we are creating two subscribers. Again, we are using a flow in order to handle the back pressure. So what we do is we have four methods here that we are implementing, right? First one is the subscribe, on next, on error, and on complete. So basically we are telling our subscriber what to do when it just starts to subscribe, what to do when it's on the next, right? So here we are defining the back pressure, right? So we are defining how many items this specific subscriber should handle in when it starts first, and then after that, one by one. In this case, we are handling it one by one, but it could be like let's say that we can put here 2 or 3 or whatever value we want. But let's say how many events our subscriber can handle, right? So here what we have, so we are it's a stock price stream, so we are streaming a stock prices, and the first one is that we are displaying that we have two asynchronous jobs, right? Subscriber 1 displays those events, displays those prices for the stocks on the dashboard, and we have another subscriber which is that the log to the database. Right here we have exactly the same. So we have two subscribers. The first one is that showing that on the dashboard, and another one logging to the database. So here again we are implementing four methods, and we are defining that what should be for each case, right? For each case, what should we do? So whenever our subscriber starts, then we are consuming one event, one item, one event at the time, right? Then here, what we do is we are simulating some work, saving to the database, and again, we are consuming, as the next step, we are consuming again one event. So we are consuming event, as long as we have events, we are consuming events one by one, right? And on the error, we are throwing this message. We are returning so whenever we cannot handle the event, that's the error that we are throwing. And on the complete, we are logging again that the DB logger stream closed. And here what we do, right? We have already created a publisher and we have two subscribers. So we are registering our subscribers in our publisher. Again, if you have seen the observable design pattern, that's what exactly we do in the observable design pattern also. So here we are registering our subscribers, and we are starting the stock price stream, right? So here we just have we have a value for the stock prices. Let's say for the Apple, we have here some values, some random values here, and we are publishing those events. So we are one by one publishing those events to the so we are publishing those events, and we want to see that how they are subscribed by our subscribers, and we are simulating the live feed. We are publishing them every second. So then after we finalized all our work, we are closing the publisher in order to not waste the resources, and also we are printing this message, and we are keep the thread alive in order to print all the values. So that's it. That's all we have here. The important points to pay attention. Again, we are using a flow, right? Flow interface here, and also that how we are handling a back pressure, right? Whenever our subscriber starts here, it processes one message, And on the next one, on the next means that on the next message, it again fetches from the list of the events, fetches one event at the time. So we can again increase that to 2 or 5. If we put here the value of the long maximum, it means that it will process, it will basically, it will try to process all the messages at once. So now let's run it and see that it exactly works as we expect it to work. Let's run it. Okay, as you can see here, so we are starting a stock price stream and we are receiving the event, and we are asynchronously, what we do, we are logging that to the database, and we are also showing that on the dashboard, updating the dashboard. So we can publishing, we are saving to database, and we are showing updating the dashboard. So at the end we are closing our publisher, so not to waste the resources, and our subscriber also exit because there is no event to process. So that's in a nutshell how Flow API works. So now let's go back to let's go back and see what we have, right? So again, a Flow API, it's you mainly used for the educational purposes, but if let's say you want to create the production level in the large project, usually we are using other frameworks and APIs that we are going to talk about now. So the next one is that the project Reactor, it was created around 2016. So basically Project Reactor is a foundation for the Spring Web Flux. So it introduced two entities. One of them is the Mono and the Flux. Mono is basically that we are emitting only one event at the time, right? So in the back, it's a back pressure aware, which means that it handles the back pressure out of the box. Next one is that the Spring Web Flux, it was introduced starting from the Spring 5, starting from the 2017. So basically for the Spring Web Flux, so what we have here is that, for example, right here we have endpoint hello, and we are returning one event. We are using Mono. As I said, Mono means that we are just emitting one, we are sending one event. So here we are sending hello reactive world asynchronously. And the advantages of it is it's a non-blocking, it's built on top of the Reactor native, and it's great for the high concurrency APIs. So now let's take a look at we have seen all the options that we have. Now let's see that let's take a look one more view on the ecosystem of our reactive programming in Java. So language level API. Language level API, we are using Java 9 Flow. It's part of the JDK. So for the reactive libraries, we have a Reactor, and we have the RxJava. We have RxJava 1, and we have RxJava 2 that was introduced by the Netflix. It's for the async pipelines, and the Reactor is Spring Web Flux is based on the Reactor. For the frameworks, we have a Web Flux, and we have also Akka, so for the reactive web, right? Web Flux is basically that we are using Flux for the web, right? Meaning that we are using that for the web applications. And for the large system, for distributed systems, let's say not part of the one. So if we have several downstream systems, and we need to better scaling, and we need to better management of our resources, then in that case we can use Kafka for the larger systems. And let's summarize and put some recommendation here. So we have, as an APIs, we have a Future, we have RxJava 1 and 2, we have Flow API, we have a Reactor, and we have a Web Flux, right? So all of this except Future and the RxJava 1, all of them are handling the back pressure, and all of them are non-blocking, except Future. Again, Future, you should use that carefully because it can be blocking, as we have seen earlier. And usage of it, Future and the RxJava 1, they are usually used in the legacy applications, and Flow API for the educational purposes, and the Reactive Web Flux used in the reactive web or in the large applications. So the final recommendation is that if you are using a basic asynchronous calls, right? Basic asynchronous application you have, in that case, using a completable Future would be enough. But if the project is larger and you need much more more ways how you can um, manage your resources, and how you can manage the that better control over your APIs, then in that case you should go with the Reactor and Webflux. And for the distributed systems, you should go with the Kafka.